This video is presented to you by www.testprepadda.com. Dear students, in the previous video lecture, I talked about the inductive effect. I talked about positive inductive effect. I talked about negative inductive effect. I gave you the examples of those groups which show positive inductive effect. Positive inductive effect means electron releasing tendency. I gave you the examples of those groups which show negative inductive effect, means electron withdrawing tendency. Dear students, electron withdrawing nature or electron releasing nature, this is the characteristic of the group. But sometimes it is possible to explain this theoretically. In this session, I will tell you how to compare the inductive effects of different groups. What are the different points? First point is electronegativity. Electronegativity of the element attached with carbon chain. For example, if I take F and Cl, carbon chain, the group F, carbon chain, and with this carbon chain Cl is attached. We all know that the electronegativity of F is greater than Cl. So what can we say? Electron pulling tendency is greater than Cl. For F, the electron withdrawing tendency is greater. So in case of F, the positive charge developed on carbon will be greater than positive charge developed in case of Cl. So this delta plus is actually greater than this delta plus. The point is clear. This is electronegativity. Now the second point. Second point. If the atom of the group which is directly attached with carbon chain has actual positive or negative charge, then its inductive effect will be more. Actually, if the atom which is directly attached with carbon chain has actual positive charge, then its minus effect will be more. Similarly, if the atom of the group which is directly attached with carbon chain has actual negative charge, then its plus I effect will be more. I will explain this. If I take the example of NH3 plus and F, these are the two groups. Take the carbon chain and attach this first group with the carbon chain, and again you take the carbon chain and attach F with this carbon chain. Although F is more electronegative than nitrogen, but here this NH3 group has got plus charge, and that is why its minus I effect means electron pulling tendency will be greater than F. The electron pulling tendency of NH3 plus is greater than F, and that is why the delta positive which will be developed here will be greater than the delta positive developed here. My point is clear? Similarly, for plus I effect groups, if I compare O minus and CH3, if I attach this O minus with the carbon chain, take this carbon chain, attach O minus, take the carbon chain, attach CH3. CH3 has got electron pushing tendency. O minus has got the electron pushing tendency. But here this oxygen has got the actual negative charge, and that is why the plus I effect of O minus will be greater than CH3. My point is clear? Dear students, not only this, if you compare NHCOCH3, this group, and NHCH3, both these groups show minus I effect. Both these groups show minus I effect. And you can see there is no actual positive or negative charge on the atom which will be directly attached with carbon chain. Although nitrogen here does not have positive charge, but but if you if you look at the structure here, lone pair of nitrogen is in conjugation with the double bond, means resonance is there. And if you write the resonating structure of this, it will be like this. So, although here it is no positive charge, but in the resonating structure you can see there is a positive charge. While in case of NHCH3, lone pair of nitrogen is not participating in the resonance. That is why nitrogen is not getting any kind of positive charge. And that is why we can easily say that the minus I effect nature of NHCOCH3 is greater than NHCH3. My point is clear. Now, if I take a question here, like if I compare OH2 plus OCOR and OH, these three groups for the inductive effect. All these three groups show minus I effect. But look at the three. This first has got the actual positive charge. Actual positive charge. So its minus I effect will be the greatest. Its minus I effect will be the greatest. Now you have to compare these two. In the first case, if you write the structure carefully, you can see this lone pair is in conjugation with the double bond. So if you write the resonating structure, you can see the positive charge on this oxygen. Positive charge is developed here, and this O you are going to attach with the carbon chain. So its minus I effect means electron pulling tendency increases, but it will be less than the case where atom has got the actual positive charge, but it will be greater than the OH. So whose minus effect will be the greatest? This one, then second, then third. My point is clear. Similarly, you can say NH3 plus greater than NHCOR greater than NH2. The minus I effect order. My point is clear? Okay, now I'll take the third point. Here I have written the hybridization. Now if I take the example C triple bond CH, CH double bond CH2. These two are actually minus I effect groups. Minus I effect groups. Now if you attach these groups with the carbon chain, so this carbon is going to get attached with the carbon chain. This carbon is going to get attached with the carbon chain. If I ask you, the hybridization of this carbon, it is sp. If I ask you hybridization of this carbon, it is sp2. If I take another example, CH2CH3, what is the hybridization here? sp3. And students, let me tell you, more more S character implies more electronegativity of carbon. More S character implies more electronegativity of carbon, and this way if you compare the three groups, this carbon is the most electronegative. So if you attach this group with the carbon chain, the electron pulling tendency will be the maximum. So what conclusion we can draw from here? For minus I effect, here, the sp hybridized carbon will show greater negative I effect as compared to sp2 hybridized as compared to sp3 hybridized. My point is clear? If I ask you to compare the inductive effect of C triple bond CH, then aryl, and then vinyl group. If you compare the inductive effect, all these three groups show minus I effect. Now, first of all, just find the hybridization of the carbon which will be directly attached with the chain. So, what is the hybridization here? sp. What is the hybridization of this carbon? sp2. What is the hybridization of this carbon? sp2. So, sp carbon, the electronegativity is highest. That is why its inductive effect will be the maximum minus I effect among these three. Now, if you compare these two, out of these two, although in both the cases the attached carbon will have the same hybridization, the phenyl group will show greater negative inductive effect because of the internal resonance. This carbon will get positive charge. The point is clear? So here I can write the inductive effect for first greater than second greater than third. Okay. The fourth point, you can see more number of carbon atoms in the chain. Actually here I am talking about the alkyl group. Alkyl group, we know it shows plus I effect. It shows plus I effect. So more number of carbon atoms present in this alkyl group, more will be its plus I effect. For example, if I write CH3, CH2, 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 its plus I effect will be greater than CH3, CH2, CH2 will be greater than 2 carbon alkyl will be greater than methyl. My point is clear. So more number of carbon atoms in the alkyl group, more will be plus I effect. Similarly, if I talk about the ring of 6 carbon atoms, ring of 5 carbon atoms, ring of 4 carbon atoms, ring of 3 carbon atoms. So obviously the plus I effect will be more here, then this, then this, then this. Now fifth point is branching in the chain. More branching, more plus I effect. For example, if I take this only, this is normal butyl, CH3, CH2, CH2, CH2. If I do the branching like this, CH3, CH2, CH, CH3. So here you can see 4 carbon atoms, here also 4 carbon atoms. Now CH3, CH, CH3, CH2. Again 4 carbon atoms. Another example I'll take here, CH3, CH3. Here also you can see 4 carbon atoms. This is normal butyl. This is secondary butyl. This is isobutyl. This is neobutyl. As I told you, more branching implies more plus I effect. So least will be for this. And here you can see this is going to get attached with the carbon chain. So the carbon atom which is directly attached with the carbon chain has got so many branches, and that is why its plus I effect will be maximum. This is maximum. This is minimum. Now out of these two, in which case the carbon which is directly attached with the chain has got more branching, this one. That is why you will say number 1 here, number 2 here, number 3 here, number 4 here with regard to the plus I effect. My point is clear. If I take the example, this one CS3 is attached here, one CH3 is attached here, one CH3 is attached here. Now this group is going to get attached with the carbon chain, carbon chain, carbon chain. Look at the carbon atom here. You can see all three will show plus I effect, but in which case the attached methyl group is closest to the carbon which is attached with the carbon chain in this case. So this will be the number 1, and then this is the number 2, this is the number 3. Point is clear. So these are the different points, by which we can compare the inductive effects of different groups. Dear students, in the next video lecture also we will continue the discussion of inductive effect. We will talk about the applications of inductive effect. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.